serve as an introduction to solving systems of equations, focusing mainly on solving by graphing. So graphically, a point xy where two lines intersect is considered the solution to the system. So what we're going to be doing, we're going to be graphing two lines together at the same time in the same plane and trying to find a point where they intersect. And then algebraically, the intersection point would be the xy value that would make both equations true if I were to evaluate both equations for that particular point. So let's do a little model demonstration of what I'm trying to talk about. If lines intersect, and we'll just do a little visual in your notes. If lines intersect at a single point, then that's considered a solution, a system that has one solution. If I graph lines that actually don't intersect because they're running parallel to each other, that is a case where I would have no solution. Or if I try to graph a system and the lines actually are the same line, just multiples of each other, this is a case where I would have infinite solutions. So let's go back a page and let's do a little bit more analysis on a closer level with this. So let's graph the pair of lines given in the first example. This is my one solution example. So I start with a y-intercept of 3. My slope is positive 1, so there's my first line. I'll graph the second line in red. It starts at the origin, and my slope is negative. And I can see that the two lines have intersected at the point -2, +1. This serves as the solution to this system. Visually, it's where the two lines intersect, and if I were to evaluate each equation for the xy value, -2, +1, I would see that I would get a true outcome both times. I can see that both check, so algebraically, it's the xy ordered pair that would make both equations true at the same time. Graphically, visually, it's the point in the plane where the two lines would intersect. Let's analyze what happens when we're graphing parallel lines with or lines that have the same slope but different y-intercepts. And here I can see that the two lines are running parallel to each other. They will never intersect. They have no common points. So this would be a system with no solution. And then let's analyze the last system on the cover sheet. And here, if I were to graph, the first line in blue, once again, y-intercept of +3, slope of +1, and then I look at the second graph, or the second equation rather, and I see that the y has not been isolated, so I need to divide the 2 out of the problem, and when I do that, I end up with the first equation. So this is a case where the two lines the two equations actually represent the same line. If I were to graph, I would just simply be graphing on top of the line that I already graphed. So this is a case where you would have infinite solutions, infinite xy ordered pairs that would make both equations true at the same time. Let's do one together on the video. And the instructions here ask you to solve by graphing. So we're going to solve by graphing. And that means I'm going to look for the intersection point. So I'll graph the first line in blue, and starting at -8, okay, here's the point, here's my y-intercept, my slope is +1, and I'll graph the second line in red. So I'm starting at +1, and my slope is -2. And here I can see that the two lines have intersected at the point +3, -5. So this serves as my solution to the system, and it's not necessary for you to go back and verify and check each time, but if you wanted to, if you were to slip those xy values into each equation, you would see that they're both true with this outcome, with this xy ordered pair. Let's look at the second, number 2 together on the video. So all you're doing, you're just graphing the same, you're graphing two lines on the same grid, and you're trying to find the location where they intersect each other. and then that becomes the solution to the system. So here I start at 9, and my slope is 1/2, positive 1/2. Oh, I graphed it backwards. Wait, hold on. Okay, let me start that one over again. I'm starting at positive 9, and my slope is down 1/2, down 1/2. Okay, and then that's the first line, and let me graph the second line in blue. I start at positive 6, and my slope is -1. So I can see here's my intersection point. My intersection point is the point -2, +8. -2, +8 serves as the solution to that system. So I think that's enough modeling and enough presentation for you to take it from here. Just carefully graph each line, and then we'll pick up the conversation in class.